feeling a little less colorful today. Actually, I look a little less colorful. I don't know if it's my monitor, but maybe a little. You see me okay? All right. It's just okay. All right, we're good. Hey, welcome. We're almost done. This is amazing. Let's see. According to the school calendar, next Wednesday should be the last day of class. Finals will start next Thursday. Now, I don't know if you've had notification from school yet. You should be anytime they're getting you more information. We're not having finals, as it were. Since we're not in classes, we're not going to do the traditional finals format. Instead, they have like some options for you to do for your final instead of a final. And it's going to be something you can do safely, kind of fun, like take a walk on a trail and take a picture of yourself and post it. So I don't know. I haven't seen all the options yet. I just heard there's going to be some different fun things like that. It's not nothing where you're going to have to crack open a book. You're going to have to study. You're going to look up an answer about your questions. No, that's not it. No, enjoy it. This will be your best finals ever, because it's not going to be a finals about any of these math equations next week. Right? Your grade's going to come from the work you're doing here, not from a final that we're going to throw at you at the end of the semester, because it's not happening this year. So, yay. With that in mind, that means we have this lesson today. We'll have a lesson Monday, Tuesday, and then Wednesday is our last day class. They're going to treat it like a fast Friday, so you Thursday folks, see you Wednesday. But we'll just do something fun that day. Look for some assignment. It'll just be a fun thing. Won't be a bunch of in-depth math. I mean, this is it. That's party time, right? We'll just do something. But so what I'm going to do for these last two lessons today, we're going to do some looking at solving for variables. I thought these last two lessons, Ms. Smith and I talked, and we decided what would be better to wrap this up this year is to give you a jump start into geometry. Some things that you'll use often in geometry, you need to be able to know how to do, and I just want to go back and get this refresher so that it won't be so long since you've done some of this. So we're going to do that today and Monday. It's still for a grade, but instead of our usual lessons we're doing this as a grade. So I think you'll find this today should be pretty easy. Hopefully Monday will be pretty easy. Guys, we're trying to finish easy and strong here for you guys. Make it where you go away feeling good for the summer. All right, let's see what we have prepared for you today. No, that's not what we have prepared for today. That's just something I thought. And I hope you have that look often, right? No! Yes, so, yeah, I want you to get there. I want you to be there today. I want you to be there all the time. This is what we're going to do today. We're going to solve, well, we call it solve for x, but this isn't x. Remember, when we have an equation, it's to solve the equation. Usually, what you've seen all the time is 2x equals 6 or something. X is a variable. It's just a common letter that was chosen to represent an unknown number. But it doesn't have to be x. You have y. We do that in our equations of a line. Y equals 2x plus 3. And the y and the x both just represent a number, which is a point on the graph. The point 2, 3. The 2 goes in the equation for the x. The 3 goes in the equation for the y. The x and the y are just placeholders. They just hold a place. And that's all that happens with these. I've got R, I've got S, D, V. I'm not even sure if I have an X in here. Maybe there's an X. It doesn't matter. It can be any letter. It's just holding the place of a number that we don't know yet. It's just a variable. So variables can be any letter. So start off easy. Some of these you're probably like, well, I already know the answer to all these. I hope so. And yours are going to be just as easy as these are. All right. I'm not going to give you something. It will not take you long to do your homework. I hope you just fly through it. Negative 18 equals negative 2r. How do we find out what r equals? Negative 2 is being multiplied by r, so we have to do the opposite. Divide by negative 2. Negative 18 divided by negative 2. Negative divided by negative. That's positive. 18 divided by 2 is 9. R equals 9. All right? 2s equals negative 18. Oh, kind of looks a lot like the equation above it, except above was the negative 2r. This is 2s. I'm going to get s by itself, divide by 2. This time we have a negative divided by a positive. So 18 divided by 2 is still 9, but a negative divided by a positive is negative. So S equals negative 9. Negative 9. D divided by 5 equals 8. Oh, divided by. Man, what are you doing to me? I know what 5D I could do, but D, it's just the same principle that we do in these others. Whatever that 5 is doing to D, we need to do the opposite to D to get rid of it, right? This 2 is being multiplied by S. So if we want to get rid of the 2, we got to divide by 2. Multiply by 2, divide by 2. This time we're dividing by 5, so multiply by 5. 5. So if I take D and I divide it by 5 and then I multiply it by 5, those cancel each other out. Boop. D equals 8 times 5. D is 40. Oh, wonderful. 40 divided by 5 equals 8. Remember, if we want to check anything, if I said that's what it is, I just put it back into the equation for the variable and see if it's true. It's 40 divided by 5 equals 8. Yes, you can always check your answer this way. Any kind of equation, when you come to something and you say, oh, D equals 40, you should be able to put 40 back in for D. All you have left is numbers then. See if it's true. If that ends up not true, D is not 40. In this case, it is true. 44 equals 4 times V. I'm going to divide by 4. Divide by 4. V equals 44 divided by 4? 11. If I substitute that back in, 4 times 11, that is 44. So I can double check it and know I am absolutely correct. This is good. Are you getting that look? Yes. All right. B minus 5 equals minus 5. Well, if I add 5, because this time since I'm subtracting 5 from B, I got to add 5. Got to do the opposite. B equals negative 5 plus 5. B must be 0. Because if I'm going to subtract 5 from B and end up with negative 5, I must have started at 0. Oh, got 2 steps now. All right, got a little more going on. Negative 25C minus 11 equals 27. First thing we need to do. This does not have a variable. We get rid of it first. Can't do anything with this while this is still hanging on. Get rid of anything. Since this is subtracting, I have to add. Since that's subtracting, add. Negative 25C equals 27 plus 11 is 38. Okay, haven't got there yet. I don't know what C is. Negative 25 is being multiplied. Don't look at that and thinking it's subtracting just because there's a minus out front. That's a negative sign. Negative 25 times C. There's nothing between the 25 and the C. That means they're being multiplied. So, C equals negative 38 divided by 25. Yes, that's an answer. Do I have to go over here and say, what is 38 divided by 25? I can, but why? That's just more work. I've already got the answer. It's a negative. Negative 38 divided by 25. That's the answer. I don't need to do more work. That's it. Okay. A fraction is an answer. 2 minus f divided by negative 27 equals 26. Where do we start? Well, here's our variable, the f. There's a 2 with it. I can't do anything with that yet until I get rid of this negative 27 that's dividing. Right? Dividing by negative 27. So let's multiply by negative 27. These will cancel each out. If I divide by negative 27, then multiply by negative 27, I just get whatever I started with. 2 minus f equals. What's 26 times? That's not minus, that's a times because I had to multiply it over here. 26 times negative 27. Okay, that you might want to use your calculator for, right? So 26 times, oops, not minus, times negative 27. That is negative 702. 2 minus f. 2 minus f. There's a 2. I need to get it out of here. So that's minus 2, because right now it's a positive 2. So if I subtract 2, now I have negative f equals negative 704. Negative 702 minus 2 more. Negative 704. F equals. No, I don't have f equals. I'm not quite there. This is negative f. This is the opposite of f. The negative f. Negative 1 times f. Negative f is the same as negative 1f. So f would be positive 704 if negative f is negative 704. Same thing as divide by negative 1, divide by negative 1. Divide by negative 1, it turns it positive. So f equals 704. If you need to watch that one again, back up a minute. Not a big problem. All right. This is the last ones we're doing together. Then I'll have some very, very similar to these for you to try. And then we'll wrap it up for today. Next week, we're going to talk about an old Greek mathematician, buddy, that we will use a lot in geometry. So, Monday, you want to get this. I'm sure you've heard of him, Mr. Pythagoras. Okay, 22 plus 1/6 b equals negative 2. 1/6 times b. What do I need to move first? Well, the 1/6 is being multiplied by the b, but I've got this over here that doesn't have a b. Got to move that. That's a positive 22. So I need to subtract 22. So I have 1/6 b equals minus 2, subtract 22. Negative 2 minus 22 more. Minus 24. 1/6 times b. Almost looks like 1/6 times 6. That's a b. So we can divide by 1/6, which is the same thing as multiplying by 6. You can do it that way. So we divide by 1/6. Divide by 1/6, just for consistency's sake. So if I have negative 24, and I divide it by parentheses 1/6, see, my calculator's fine with doing that, and it'll say, oh, that's negative 144. Because it's the same thing as multiplying by 6. Because if I multiply 1/6 by 6, that makes it 1. So I can multiply by 6, and either way, get to the same b, same answer, 144 negatory. All right, so b is negative 144. Don't let fractions mess you up. Treat them just like other numbers. Just figure out how to get rid of the fraction. Look at this fraction, 24 minus a. Yes, I am right. I didn't have an x on here. 24 minus a divided by 18 equals 26. Okay, we have the variable on top. It's being subtracted from a number. And then all of that's being divided by 18. So the first thing we have to do is get rid of that 18 that it's being divided by. So the opposite of that would be multiplying by 18. Since I divided by 18, now I will multiply by 18, which means those will cancel each other out. I have 24 minus a equals 24 minus a. That's not a 2, that's an a. Trying to make it look more a-ish. 26 times 18. You got that one off the top of your head? We'll go ahead and let you use a calculator on that too. 26 times 18 is 468. 24 minus a. Positive or negative 24? That's a positive. It's subtracting a. It's positive. So subtract the 24. So negative a equals 468 minus 24. 4. Negative a equals 444. So what does a equal? Because that's negative a. That's negative a there on the page. So positive a would be negative 444. Negative 444. All right. We're cruising right into the home stretch. This is it. S minus 14 divided by 10 equals 11. So, divided by negative 10. We got to multiply by negative 10. Got to do just the opposite. Times negative 10. So, that leaves S minus 14. 11 times negative 10. Negative 110. Okay, S minus 14. S minus 4. We're subtracting 14. We need to get rid of that by adding 14. S equals negative 110 plus 14, negative 96. All right. We started out the year doing some solve for X type stuff. We didn't use those big numbers. We didn't have 444 and 96 all the time. We used like 7 or negative 3, right? It can be anything. It can be a fraction answer. It can be a big number. It doesn't matter. It's the same process. Just want to make sure you do that. This is something that's not just geometry. This is something that is Algebra 2. It's any math is being able to have a variable in the equation, and solving to figure out what the variable equals. All math. So that's why I wanted to come back. We wanted to hit this skill again, just as a reminder, refresher. This isn't real difficult problems. We're not doing, we didn't do x squared and weird things like that. Square root of x. We're not, I just want to hit back to the very basics. So, like I say, join us Monday, Tuesday, whichever day is your math day, and we'll go back into Greek, and I'll try not to speak in Greek, because nobody will understand that, including me. But we'll talk about our old buddy Pythagoras and what he gave the world a couple thousand years ago, longer than that, because he was a couple hundred years. He was about 400 years BC or so, 450, a ways back. So 2,500 years or so since we've had Mr. Pythagoras. So until then, do work you can be proud of. We'll see you next time.